Hello, in this talk we're going to talk about disk partitions and volume management, particularly in Windows 10. Well, actually we're going to focus not so much about Windows 10 and a lot of general theory. Just as a basic concept, we have internal disks and we have external disks. Internal disks can use SATA technology, SCSI technology, and IDE technology. Essentially, what we're going to end up with is, I'm going to do a lot of drawing in this talk, is we're going to either have SSD hard drives or platter hard drives. SSD is essentially just memory banks inside a hard drive. All right, and it's going to keep its ones and zeros, right? And record it in a very similar way as memory does. Okay, essentially that's a SSD, solid state hard drive. Okay, they tend to be faster, especially with quick reads. SSDs will read data, particularly small transactions, much quicker than say a platter drive. All right, a platter drive is what most people have on their computer. Essentially, it's comprised of a bunch of metal disks that spin at various speeds. You can have 5400, 7200, and some newer speeds, 96,000 or 9600 and 10,000. Anyway, there's going to be heads. These heads are on both sides. They read both up in the upper part and the lower part of the platter as it spins around. Okay, so this platter is going to keep spinning around. And what happens is these heads kind of read the magnetic properties of the metal plate. Okay, if it has a certain amount of magnetic property, then it's a 1. If it has another magnetic property, it's a 0, right? And at the end of the day, all we really care about are 1s and 0s. So that's platters and SSD. We have external disks. They're going to use USB, eSATA, Thunderbolt, etc. We have thumb drives. We have external hard drives. But the point is they're going to be kept externally of the PC. All right. Another massive point here that's very important that I bump into often is that external disks are going to be slower than internal disks. Okay, if you look at a motherboard, there's just simply more connections going for an internal disk than an external disk. There's more bandwidth to be had, and so therefore external disks are going to be more going to be slower. Okay, and internal disks are going to be quicker and faster. All right. So we have virtual hard drives as well. A good example of a virtual hard drive is one that you're using in your labs, actually. If you go, we'll go to File Explorer, and let's go to my okay. We're gonna, I know why. All right, so we go to File Explorer, and we're gonna go into Documents, and let's take a look at our virtual machines, and particularly our hard drives in our virtual machines, which come out as VMDK files. All right, if I look at a VMDK file, actually we'll look at the main one. I can first of all kind of mount it. I can map it in a computer. But let me open it up in Notepad, and you'll see it's data. This is actually pointing to the split drives that we have. A virtual hard drive is nothing more than a file. Okay, it's a file that can be opened up by Windows and read to and treated as a drive. If I mount a virtual hard drive, a VHD image in particular, which again is something we'll do in our lab, if I have this VHD image file and I map it in Windows, it's going to treat it like a hard drive. It'll give it a drive letter. It's going to give it a way to be accessed to the user. All right. The next point is we're going to keep coming back to this. Volumes and disks are often used interchangeably. So multiple disks as one logical disk. Let's just talk about volumes in general. Volumes can be is Microsoft's term to incorporate something that is read by the hard drive as a volume, as a C drive or something like that. That is a volume. Okay. When I hear the word disk, I think of a actual piece of hardware, right? A disk. In theory, you could have a volume, particularly a dynamic disk, multiple disks become a volume, right? We can have a D drive that is a stripe drive, which we'll talk about soon. So we can have it into, we can have multiple disks become a volume. So just be careful. You have multiple, you have people that use volumes and disks interchangeably. Volumes are a phrase often used in the world of Microsoft, but we tend to be talking about the same thing. All right. So let's talk about partitions. A partition on a hard drive is a logical sectioning off of the hard drive, right? When we have a partition, what we're saying is I'm going to use this part of the hard drive, right? And it's not necessarily this clean, but this sector from this sector is going to be, in the case of Windows, we'll do the C drive, right? This part over here, we're going to make into, we'll talk about this logical partition. We'll make this an extended partition, and within that extended partition, we're going to have logical drives, and that will be the D drive, right? And then we'll make this the F drive. All right. So what we're saying here is essentially partitions is a logical division of the hard drive. All right. We have a couple different technologies. We got MBR, which is really old, actually. It tends to be used with BIOS. It is quite a bit older. It uses a 2 terabyte limit, so that's been a limiting factor. As hard drives are starting to get a little bit bigger and bigger and bigger, it can only do terabytes. That has to do with how big the database is. A partition table essentially is the two-dimensional flat database of where partitions begin and end on a hard disk. Even if there isn't partitions, you have one partition, right? And that partition has to be recorded in a database, okay? There's a 2 terabyte limit in MBR because of the amount of memory used to record that information, all right? We have GPT, which is a GUI partition table, which is the newer standard. That's what the G stands for, GUID, which is a globally unique identifier. Partition table, that's used with UEFI, Unified Extensible Firmware Interface, which we've already talked about. That's what was replacing BIOS. It uses GPT. It doesn't have a 2 terabyte limit. The limit is astronomically high as far as how big it can handle. But this partition table is what's going to list the various partitions. And if it's a primary partition or a single disk with just one primary partition, it has a boot sector somewhere on it, it will list where that boot sector is. This is what UEFI or BIOS, if we're doing MBR, it's BIOS. If we're doing GPT, it's UEFI, is going to read in order to get to the operating system. We'll just put the operating system in this section here. That's what's going to get to that operating system, all right, because it needs to be initialized. The boot sector says, hey, start reading the operating system here, loading up to memory, and we can actually boot up the actual device. So we have primary versus logical partitions. A primary partition is just that. It's all drives have at least one primary partition. That's going to be the primary partition. In fact, boot drives, any drive with a boot sector needs to be a primary partition. All right. A logical partition, and this kind of goes back to the early days. We would really like to put multiple partitions on a hard disk. You can credit the fact our files were really small or something, but we tended to do that, and that ended up that thing where we'd have one primary. So I'll put pri here. All right. And then what we'd have is what's called an extended partition, and then logical partitions inside of that. And I can create multiple logical partitions in an extended permission. So we'd have an extended, and then we'd have our logicals. Okay. So the logicals would give me the drive letter, by the way. All right. So my primary, let's just pick on C drive. It's the basic one. We'd have a logical of a D drive, right? And then we have another logical. We'll make it the F drive. And we can make it an E drive and go in order. All right. Also notice there's no A or B, right? Those drives in Windows are reserved for drive letters, which we'll talk about, is reserved for disk drives or floppy disks. So just keep that in mind. Not CD-ROM. CD-ROMs tend to get a D drive or a different drive. But so we have file systems, sectors, clusters, and tracks. So what a file system needs to do Again, here's your hard. We're going to focus on platters, but in any case, we're going to sector out the memory. All the space that can be written to, we're going to sector it out, and every sector, every little part of the platter is going to be sectored out. Okay, and then we're going to turn that into clusters. It's just we can't keep a database of every single cluster that tend to be or sector that tend to be too small. So what we're going to do is we're going to have clusters that we can write files to. Think of them like storage cabinets. Now, a lot of times the files are too big, especially if we have a massive size file. But a file might eat up this entire cluster here, but only eat up part of this cluster. Okay, so that's the first part, that's the second part, that's the third part. And they don't need to be next to each other. We'll talk about that a little bit later when we talk about tracks. But so the bigger the cluster, the good news is the database, the actual the table that contains the location of all data tends to be smaller because we have less of it, so it takes less processing power to record it all. But it tends to be a little bit more wasteful if we have lots of small files, because again you're putting smaller packages in storage spaces, so therefore those storage packets might eat up more space than they really need. All right. So anyway, that's a cluster. Cluster is a collection of sectors made by the file system. A file system is a way to organize it. Here in Windows, we're going to talk a lot about NTFS. We'll talk a little bit about FAT32 in the next lesson. In Linux world, you have ext3 or ext4. Every operating system is going to have its preferred file system. All right. Here in Windows, we're going to talk primarily about NTFS and FAT32, like I said. So, tracks. One last concept to get over. So, as we store data, and remember, a hard disk is taking lots of read and writes. It's very transactional. Lots of small read and writes are happening all at the same time, right? So sometimes what might happen is part of my file, we'll just make a 1 here. We'll go there. Part of it will go here. Actually, that's not good, but we'll make it work. And 2 will go here, right? So I have different parts of the drive. And this is my head going back and forth reading the data. Again, the drive spins, right? As it spins, my head's going to read part of 1, skip right by 3, right? And then come back around to 2, all right? That's not efficient. So what we call that is fragmented. When the file becomes fragmented, ideally what we'd have is the file lined up 1, 2, 3 in a row in kind of a track-like formation, right? We're going back to the old records where we have a single track that kind of spins around and around and around. That would be a track, right? We're trying to get that whole track-type feel to the file. That way it's most efficient for the reader to read the data. Okay, if the file becomes fragmented, that's called a fragmented drive. Back in the good old days, we had to defrag our hard drives to get maximum performance out of them. However, modern day operating systems, Windows 10 in particular, tends to, defrags the hard drive automatically on the fly. All right, so we have, what's the difference between a disk, a partition, and a volume? We certainly in IT, you're going to bump into people that use these phrases interchangeably. And it's so common, it's not a big deal, to be honest. So I like to think of a volume as a logical extension of a disk, right? A volume could have multiple disks. It's the logical definition of a disk. While a disk is the actual physical disk, and partitions is a logical division of a disk. Okay? That's the way I look at it, but again, it can be a little confusing. Microsoft is the only one that really uses the term volume. A lot of times they'll call the C drive, right? Another thing people like to call it is the C drive. They would call that a volume, right? So just keep that in mind. All right. Okay. I'll try. I'll probably end up using them interchangeably too. It's an extremely popular thing to do in the world of Microsoft. Let's talk about the difference between a basic disk and a dynamic disk. Okay, a basic disk is going to be that. It's going to be just a simple one disk, one volume, nice and simple. I have one hard drive. I have the C drive. That's my basic disk. It's the partitions are, there won't be that. There'll be one partition defined either by the MBR or GPT, and it'll have a drive letter assigned to it. Dynamic disks are going to be multiple volumes, multiple drives combined into one, and we'll talk about that a little bit, particularly when we talk about RAID. RAID is an example of dynamic disk, which is something we'll talk about in a bit. So in the world of Windows, we tend to use drive letters to define things, right? So let me give you an example of drive letters here using my virtual machine. So this is going to be after our lab that we set up, where we're going to set up multiple drives. If I go into this PC, we're going to see a C drive. Well, here's my floppy A drive, as I was talking about earlier. But here's my C drive, my D drive, which is my DVD drive. We have an F drive, an M drive, an S drive. This is particular to Windows. Windows, going all the way back to DOS, like to use drive letters to help users understand that there's multiple drives. All right. So there we go. There's also storage spaces in Microsoft. Storage spaces, we can use multiple disks, volume, network attached storage, and storage area network to essentially combine a common pool, right? Think of it like a bucket or a pool of water, where we can take water in or out as we need, so we can take out storage space out and put it in as we need it. So it's extremely convenient and highly logical as far as how it works. We don't have to worry about the actual where one storage ends and another storage begins. It's just part of this big storage pool. All right. Storage space could looks like a regular drive, and you can add data or storage space on the fly to it and take it away from it. So let's talk about RAID. RAID, we're going to talk about the three basic forms of RAID. I think it's important. This is a fundamental understanding. Later on, we could talk about RAID plus 1 plus 0, RAID 50, all these different terminologies. But there's essentially three basic types of RAID, okay, that I think it's really important to understand. So, again, we're going to have a RAID process. That could be a RAID controller, actual hardware doing some work. It could just be software, like in our virtual machines. We're going to have our virtual machines do it software-wise. But what we're going to do is we're going to use this RAID process to divvy up information. I'm going to pick on our good friend Tom Brady here, arguably the greatest quarterback of all time. But again, people like it when you argue over things because then they can spend more money in the league, I suppose. But anyway, so here we go. We're going to use 1, 2. If we have this is our data set. This is what we want to save, right? So think of this as our file or something along those lines, right? This is our data. All right. It's going to have this is what we need to save. So if it had a file location, it'd be in a directory, right? So here's our C drive. And we'll have a folder called data, right? And that folder would have a file, right? Actually, let's not do a C drive. Let's turn this into a D drive. There you go. Lowercase d for some strange reason. Normally it's uppercase. I just want to do that because it's not likely that it's possible you could have a C drive, your system volume being a RAID disk. But in this case, let's say we're doing a pure storage, right? And data, so we'd have a file, right? And this file would actually, the actual value in that file would be the 1 and the 2, okay? So let's talk about RAID 0. RAID 0 is what we call stripe. What we would do with that is we'd go into disk 0. We'd need at least 2 disks. We'd have to have 2 disks. We'd take part of the 1 and part of the 2, right? We'd send the data off from RAID into these 2 different disks, all right? And part of it would be 1, part of it 2. Now the good thing is when you write it and when you read from it, you're going to take part of that road. Think of it as like sending a convoy. You're going to go on really bad highways. There's lots of slowdowns and all this stuff. If you take that convoy and you separate it onto equally distant paths, but at least you're on two different slow paths, then that in theory should speed up your truck, your overall convoy arrival time at its destination. And that's what we're doing here, okay, is we're splitting up the traffic between two different, remember how we talked about, muddy country roads. That's kind of what we're, and when we talk about storage, that's what we're end up doing, is storage is kind of slow. So RAID helps with speeding up data saving and data reading. The other good thing about RAID 0, or striped, is we don't lose any data. So if I have a terabyte of data here, and I have a terabyte of data here, then I would have a striped drive of 2 terabytes. Now keep in mind the user would only see one drive. So in this case, let's pick on the D drive again, right? My D drive would be a 2 terabyte drive. If I read data from it, I want to know what this file says. That should be an E there, sorry. I want to know what this file says. I can look at the 2 different sections on a disk, and I say, okay, it's a 12, right? The bad news is, if I lose a disk, either disk, I'm not going to know what the data was. I'll know what the latter half of the data was. Is a 2. I just can't tell you if it was a 72, 92, 82. I don't know, right? I have no idea what it was. So that's the downside to RAID 0, okay, is you have no redundancy. So no redundancy, right? You lose no certificate storage. You gain speed. Yay, we like speed. But that no redundancy is kind of a big deal. People get fired over lack of redundancy, right? Redundancy is very important in IT, and when it comes to data security. And this is writing rather crappily, so I'm going to try to write slower. There we go. Nice 1, 2. So now back to our 1, 2. With RAID 1, what we do is we mirror it, right? So again, we got our RAID process. We're going to send data. We're going to send data to these 2 different hard drives, okay? So what we would do with mirrored is we'll create a mirror image. We're going to write the 1, 2 here. So now we have our 12. We're going to write a 1, 2 here. There we go, right? We have the same data on both sides. Why would we do that? Well, we get no speed from it, right? But what we get from it is a redundancy of data, right? So if I lose a disk, who cares? I know what the actual file was. I still know it's the D drive, or it's a 12. Also keep in mind that the user would just see a D drive, right? So even if we lose a hard disk, if I click on the D drive, I'm going to see 1, 2. I'm still going to see my data. So I have my redundancy. Bad news as well on that is I lose some storage, right? If this is 1 terabyte and this is 1 terabyte, what we're going to end up with is 1 terabyte, because half my data, because the data essentially is written to twice, so the D drive would be 1 terabyte. So in RAID it'd be 2 terabyte, RAID 0 would be 2 terabyte, RAID 1 it'd be 1 terabyte. RAID 5 is a bit of a different monster. Okay, what we're going to do with RAID 5 is, again, we have our 12. All right, what we do with RAID 5 is we stripe it, yay, right? We're going to get our speed from that. So we're going to send off data that direction, this direction, and this direction. All right. But we need a 3rd disk. So RAID 5, you need to have at least 3 disks. Okay. That's the first important fact. What you do is you put what's called a parity file. And the parity file is just a mathematical result, right? So I have a mathematical result. I know 1 plus 2 equals 3. So therefore, if I put a 1 here, a 2 here, if I lose any one of these disks, I can figure it out, right? If I lose disk 1 here, okay, disk 1 dies, and apparently so does my drawing tool. So if disk 1 dies, I still know 1 plus x equals 3. So I can go back and figure what I'm missing here. X equals 2. All right, so therefore I know what my recovered data is, which is a 2. That's what's called a parity file. All right, that's an oversimplification. In actuality, parity files are complicated complicated answer to an algorithm, but nonetheless, it gives you a basic idea, right? So if I lose a disk, I still get so I still have redundancy. Yay! The good news is, bad news is, also I get some speed out of this too because I'm writing and reading to multiple disks at the same time. So I'm taking multiple slow country roads. That's a good thing. So I get my speed. The bad news is I have to have at least 3 disks. You need 3 disks to do this. And oh, by the way, the parity file isn't on one disk. So we don't, when we write our next bit of data, we don't write a little bit on 0, a little bit on 1, and then put the parity on 2 again. We rotate which disk actually has the parity file. All right, just FYI. So there you go. So you have to use 3 disks, and you're going to lose a third of your storage. So if I have a terabyte here, a terabyte here, a terabyte here, I'm actually going to end up with, I turned to Charles Barkley for a while there, terabyte, then I'm going to end up with 2 terabytes. Okay. So we lose a third of our storage. Okay. Gain a little bit of speed, get redundancy, but we're going to lose, for every 3 hard disks, we only get the storage of 2, right? Which makes sense because we're going to have a parity file that's about the same size of one of the other, half of the file you want to save, so therefore you're going to lose a third of your storage. All right. That covers RAID, basic RAID at least. Again, later on, if you go into the servers class, Windows 2 in particular, you'll find out about different types of RAID other than that, which is really just a extension of what we just talked about. Like there'll be a RAID 1 plus 0, 0 plus 1. All right. So let's talk about disk management tools. We're going to play with these quite a bit in the lab, and you might get a little sick of them. It might drive you a little crazy at times. But if I go to desktop 3 here and I bring this up, let's talk about the disk management MMC. Again, it's another MMC. I can go there by clicking computer management. That's if I want to just waste my time with extra panes on the left or right. But I might want to do other things. So let's go full screen and we'll go to disk management. This is disk management. This is also after the lab, so you're going to see lots of disks here, right? This is disk management MMC. All right. Not very pretty, but very powerful. Matter of fact, if you go out there and spend big bucks on a Windows Server operating system, and with the CALs and multi-processor support, because you pay per processor, you could spend quite a bit of money on a Windows operating system, a server operating system. And when you open up your really expensive operating system and bring up your disk management, it's going to look exactly the same, which is good because I know how disk management works on the desktop, but it is kind of a little frustrating at times. Again, we have our actual physical disks listed right here. We have disk 3, disk 4, the CD-ROM. We have our disk drives, our actual volumes as they're defined. You can see this is the S drive, right? It's on these 2 disks, right? Because it's a striped drive, it's dynamic, right? There you go. There, where this where it says dynamic. It's so that's what you could do all kinds of things. We're going to talk about that. Let me just get back to the thing so I go through them. It's not fancy, but it's powerful. It can initialize a disk. So if a disk is what's called unknown until it is initialized. So again, this is an important concept. If when a disk first comes up, and you'll see this in the lab, the disk is going to be listed as unknown until you initialize it. You're actually going to have to initialize it until the operating system is going to be using it. All right. You can increase or decrease the size of a partition. You can create or delete a partition. You can format, which we're not going to do in this particular lab, but in the next lab we'll start formatting when we talk about file systems. Formatting puts a file system onto a hard disk. It's called a foreign disk if it doesn't belong to the computer. So if it's an external disk, it's something it doesn't belong there, it's going to call it a foreign disk. All right. We also have a disk part, right? This part is a command line tool. There we go. So let's go to disk part, PowerShell. So here's disk part. Oh, I need to run it as an administrator. If I just type that, it's gonna run it as a command line tool. Let's list all my disk. I think it's singular. There it is. Yep, not plural. So if I list my disk, it has all my disks. I can select a disk, select disk 0. And then if I do a list partitions, I think it's just singular again. Here's all the partitions on that disk. Okay, it's not pretty, but it's not as easy as disk management. But what it is great to use if you have if you're setting up a script or you're doing things obviously at a command line, right? It can be using scripts. Can do anything disk management, MMC. You can just do it with a command line instead. All right. It's not the friendliest interface in the world, but it's very powerful. All right. So that does it. Those are what I want to talk about, and so I'll talk to you on the next talk. Thank you. Bye.